In this problem, you'll use diameters and chords to find the radius of a circle. An archaeologist found pieces of a jar. She wants to find the radius of the rim of the jar to help guide her as she reassembles the pieces. What is the radius of the rim? Step 1. Trace a piece of the rim. Draw two chords and construct perpendicular bisectors. How does the construction help you find the center? The perpendicular bisectors contain diameters of the circle. Two diameters intersect at the circle's center. First, trace a piece of the rim. Draw the first chord. Then, draw the second chord. To construct the first perpendicular bisector, start by putting a compass point on one endpoint of the first chord. Then draw a small arc above and below the segment. Make sure the opening of the compass is greater than 1/2 the length of the chord. With the same compass setting, put the compass point on the other endpoint of the chord. Then draw two more small arcs above and below the segment. The intersections of the arcs are points on the perpendicular bisector. Now draw a line through the 2 points. This is the first perpendicular bisector. Next, construct the second perpendicular bisector in the same way as the first. Start by putting the compass point on one endpoint of the second chord. Then draw a small arc to the right and to the left of the segment. Make sure the opening of the compass is greater than 1/2 the length of the chord. With the same compass setting, put the compass point on the other endpoint of the chord. Then draw two more small arcs to the right and to the left of the segment. The intersections of the arcs are points on the perpendicular bisector. Draw a line through the 2 points. This is the second perpendicular bisector. Notice the right angles formed by the chords and their perpendicular bisectors. Step 2. The center of the circle is the intersection of the perpendicular bisectors. Use the center to find the radius. The radius is 4 inches. In this problem, you will find measures of segments within circles. Part A. What is the value of r to the nearest tenth? What is your plan? Find two sides of a right triangle. The third side is either the answer or leads to an answer. Segment KN is part of a diameter of the circle. A diameter perpendicular to a chord bisects the chord. Use the Pythagorean theorem. Substitute each side in. Now simplify. Find the positive square root of each side to solve for r. So r is approximately 7 6/10. Part B. What is the value of y to the nearest tenth? Remember, find two sides of a right triangle. The third side is either the answer or leads to an answer. Segment BC is part of a diameter of the circle. A diameter that bisects a chord that is not a diameter is perpendicular to the chord. So segment BC is perpendicular to segment AF. Draw an auxiliary segment BA to form a right triangle. The auxiliary segment BA is congruent to segment BE because they are both radii of the same circle. So the length of segment BA is 15. Now use the Pythagorean theorem. Substitute each side length. Now simplify. Subtract 121 from each side to solve for y squared. Find the positive square root of each side to solve for y. So y is approximately 10 and 2/10.
Got it, number 4. In the figure, how does the auxiliary line segment BA make the problem simpler to solve? I'll give you 10 seconds to answer this question. Timer starts now.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. The answer is line segment BA is the hypotenuse of the right triangle AC. So you can use the Pythagorean theorem. Excellent! Thank you for listening. If you have any questions, send me your message through Schoology. Have a great day!